The STL permutation algorithms allow us to generate all possible permutations of a sequence. The number of possibilities is given by the factorial of the number of elements. So if a sequence has 4 elements, there will be 24 permutations, i.e. 4 times 3 times 2 times 1, which is 24. In this video, I'll demonstrate the permutation algorithms on a string sequence of 4 characters. So we get our permutation algorithms from the algorithm header, which I've included here, and we're going to perform it on a string. So the string S is set to the characters A, B, C, D. Now I'm going to count all of them so we can enumerate all 24 permutations that we're going to step over. So we start with 1, so I output the first one, which is just S, the permutation we start with. And then I increment I so we can enumerate over it. And then I have a while, so the loop is a do while. So then I do next permutation, and I give it the iterators pointing to the begin and end of my string. So it's going to permute all elements in the string. And then after I loop through this 24 times, I'm going to output the next permutation after that. And then I'll output next permutation just to show the value. And then there's also a previous permutation. So I can call prev underscore permutation on that same sequence and step back a value. So I can step forward and back over different permutations. And then finally, I'm going to create another string bcda, and then I'm going to pass this to the isPermutation function. So isPermutation tells me if t is a permutation of A. So if I give it s.begin and s.end, and then just t.begin for this permutation, it will check to see if it's a permutation of it. And it is, so this should return true. So let's compile and run and see what we get. Okay, so you see here, we have 24 permutations of A, B, C, D, as expected. And then once we get to the end, it's set back to A, B, C, D, so that it exits out of the loop. But if we step over one more time, so this next permutation call afterwards, so down here, I get A, B, D, C, which corresponds to the second permutation. And then if I step back again, I'm back at the beginning with A, B, C, D. So that's what I expected.